Hi, let's discuss about this domain and range of a function. So here I have taken the question of find the domain and range of real function f of x is equal to root of 9 minus x square. So in simple words, the function is nothing but a system, okay, which is taking an input and delivering you an output with some processing happening inside, some mathematical operation. This input, whatever we can give to this system or the function, is called as domain. And whatever output that function can deliver, that is called as range. So whenever we are trying to find the domain, we have to ensure that for what values of x this function is operating properly. Properly means defining properly. So if it is not defining properly, that is indefinite, then that x values should not be given to function. So whenever we are trying to find domain means that finding values of x for which f of x is not defined. Okay, so in our case, so the function f of x is equal to square root of 9 minus x square. So now this is square root function. So it's like this function is square root of 9 minus x square. So for what values of x this function is not defined, so if we don't give that x values, then that remaining values is called as domain of the x. Okay, so the function we have chosen here is square root problem. F of x is equal to square root of 9 minus x square. What is the problem in square root function? The square root of some function, if you have anything here, this must be always positive. That is the condition for square root. So as the given function is square root of 9 minus x square, the function whatever inside this one has to be always positive. If it is not positive, if it is negative, okay, if it is negative, so then this is not defined. So we have to ensure that the values of the whole the square root function is positive. Okay, that is 9 minus x square has to be always greater than or equal to 0. Okay, if it is 0 also we don't have problem. Square root of 0 is 0, but it has to be positive. So I have taken two conditions here, greater than or equal, two conditions here. Okay, so 9 can be written as 3 square minus x square. Okay, and it is 3 minus x into 3 plus x squared. So if you take real axis here, so the values of x can range from minus infinity to plus infinity, and we have 0 here. And we need the x values where this multiplication is greater than or equal to 0. So where this is equal to 0, first we have taken this condition. So this is equal to 0 at x is equal to 3, and this is equal to 0 at x is equal to minus 3. So I have mentioned here it is minus 3, it is 3. Okay, now we got three regions. So minus infinity to minus 3 one reason, minus 3 to 3 another reason, 3 to infinity 3. And if you take this reason, you have to ensure this is greater than or equal to 0. So take some x value in between minus infinity to minus 3 and substitute it here, and then check it whether it is greater than or equal to 0 or not. So in my case, I will take example as minus 4 and substitute it here. It becomes 3 minus of minus 4 into 3 minus 4, which is equal to, okay, 7 into, 7 into minus 1, which is equal to negative. So this is negative, but we need a condition for greater than or equal to 0. That means it is positive value. So substitute some value in between this and this. So you substitute 0 means 3 into 3, which is equal to 9, which is greater than or equal to 0. So this is positive. And from here 3 to infinity, take one value, which say 4 here, and substitute it here. 3 minus 4 into 3 plus 4, okay, which is equal to minus 1 into 7, which is equal to minus 1. Again it is negative. So this is not it. So this interval, this multiplication becomes negative. This interval, this multiplication becomes positive. This interval, this multiplication becomes negative. As we required only positive values here, greater than or equal to 0. So we are finalizing the domain value of minus 3 to 3. Okay. So with this, now, so x, if it lies belongs to minus 3 to 3, then the function f of x is defined. So what is the meaning of this? If you take other than these values of x, other than this interval of x belongs to minus 3 to 3, f of x is not defined. Not defined means that, okay, so you do, what is not defined means so function is not delivering output value. Okay, this is domain concept. So and the domain is for this function is, so x belongs to minus 3 to 3. This can be written as in the inequality form like this also. So x is less than or equal to 3, so less than or equal to minus 3. This is for domain. Okay, now coming to the point, finding range. As I initially told you, for a function like this is domain. So for what values of x you can give it to a function. Okay, so for what value of a domain. Now what are the values this function can give you as output are called as range. So it is very easy to find the range. If you range means what is this? So what is the minimum value this function can deliver, and what is the maximum value this function can deliver? So range is simply nothing but a minimum value comma maximum value. If you find the minimum value and maximum value for the function output, that is enough to find the range value. Okay, so here the question is f of x is equal to square root of 9 minus x square. Already we know that x values what we can give it in the domain is minus 3 to 3. This is the values which we can give it to x only, and we want to know what is the minimum value, what is the maximum value. As there is a negative sign here, it means that it is a subtraction. This is subtraction, and x square is nothing but always positive because it's a square. So negative value also negative. If you give negative minus 3 whole square, it becomes positive. So as it is already positive, no need to check it for minus 3 to 0. Minus 3 to 0 is no need to check it because it is taking only positive values. So take x values as 0 to 3 only. Okay, so this is input values, we are giving input values. Okay, now check it for this function. What are the minimum value, what are the maximum? Substitute 0 here. Okay, 0 square means 9 minus 0 square. So what you are getting here, square root of 9, which is equal to 3. Okay, now substitute this maximum value here. It becomes, so when x is equal to 0 here, when x is equal to 3 here, f of x is equal to square root of 9 minus 9, which is equal to 0. Okay, so if you observe it here, this is the minimum value you are getting as a output of this function. This is the maximum value you are getting as output of this function. So combining this both, it becomes, so the range of function f of x is equal to, so the minimum value comma maximum value, so which is equal to 0 comma 3. So finally the function f of x is equal to root of 9 minus x square. Domain is, okay, so minus 3 to 3, and range is 0 to 3. Thank you. Hi. So the next topic is about continuity. Okay. The continuity is nothing but for a function f of x. Okay. So to check whether the function f of x is what is so as I told you, here we have input here and this is output. So input we again call it as domain here and it is range here for any system. Okay. So if you give any domain values, any x values here as a domain, and there is a output called as y here. Okay. So for different values of x, if we have different values of y without any gap, without any discontinuity, then we call it as the function is continuous. Okay, I can explain you in the by taking example of a graph. So we have x values ranging from minus infinity to plus infinity on a scale. Okay, for different x values, from minus infinity to infinity, if the output, the y, if you analyze this, if it is something like this, continuous without any gap, any gap, I mean there's no undefined values, I mean there's no y value, undefined value, then the function is continuous over some interval. If x belongs from minus infinity to infinity, we'll have y defined value for all x values. This is for over interval. Now, at single point, if you want to know whether it is continuous or not, this is for over interval. For a point means, so say we have a curve like this and you want to know at some point a whether this function f of x is continuous or not. So continuity is always relative. Relative means it is a comparative. At a single point, if you have some y is equal to f of a, we cannot say that it is continuous. Continuous at some value of x is again a comparative. So you cannot check at if you have a value at x is equal to if you have f of a, you cannot say it is continuous. You have to move forward x is equal to a plus h. And if you have some value called as f of a plus h here, and backward say x is equal to a minus h, f of a minus h. So in order to check continuity at x is equal to a, we need three values, that is f of a plus h, f of a, f of a minus h. And if all these three are same, then only we can say the function is continuous at x is equal to a, and h it is almost equal to 0, and h it is almost equal to 0. This is the way of checking continuity at a single point. This is a way of checking the continuity at over interval. Okay, so let me explain you this concept with an example. Okay, so let me take the function called as f of x is equal to step x. Okay, what the step x is? So it takes the value of n when x lies between n to n plus 1. Okay, so lowest where n belongs to integer, lowest integer value. Okay, so say like example of if you have 2.1, where this 2.1 on the scale, it lies between 2 to 3. So take the lowest integer, so this is 2 here. Okay, if it is minus 2.1, it lies between, okay, so minus 3 to minus 2, here it is minus 2.1. So for this lowest integer is minus 3. So like this function behaves. Okay, now if you take at a point called x is equal to 2, x is equal to 2, you're not checking at a point continuity at x is equal to 2 for function f of x is equal to step 2. Okay, so step x. For f of x is equal to step x. For x is equal to 2, we have to take 3 cases. X is equal to 2 plus, that is x is equal to 2.00001. X is equal to 2. X is equal to 2 minus, that is nothing but 1.999999 something. And when you give input as x is equal to 2 plus, that is limit, okay, h tends to 0, okay, x plus h. So if you apply here, this is step of 2.00001 is equal to lowest integer of this is 2 here. And if you substitute x is equal to 2 directly into step 2, again it will give you 2. And if you substitute here 1.999999, it will give you lowest integer of this is 1. Now see, for at x is equal to 2, okay, for 2 plus like 2.1 to 1.9. So these two are same, 2 is equal to 2, but this is not same, this is equal to 1. So that's why we can say that, so the function f of x is equal to step x is discontinuous at x is equal to 2.